All right, today's lesson topic 3.3, which is more special angle pairs. We're basically going to be looking at some more examples of what we did in our previous assignment. All right, so let me pull up our first example. Example 1, we have a figure similar to what you see here, and it wants us to find the value of x. Now, from what we've learned before, this right here means that this angle equals to 90 degrees. Now, another thing that we also know is that we have a straight line here and another angle coming off of it, so these two together are called supplementary angles, which they equal 180 degrees. So, we can do one of two things. We can either take this, add 90 to it, and then we can then subtract or then set equal to 180, or we can determine that this angle is the same as this angle over here. So we can simply go over here and we can put our equation. We can say our 3x minus 6 is equal to whatever we have on this side, which we know is 90. And since we don't have anything in front, we can go ahead and take out of our parentheses. 3x minus 6 equals 90. Add 6 to both sides. 3x is equal to a 96 at that point. Divide both sides by 3. You'll be left with x is equal to 32. And that's what it's asking for. It's asking us to solve for the value of x, and that is what we'll have right here. Be sure to put your rectangle around your answer. Alright, let's move on to example 3. Example 3, you'll have a figure similar to what I have drawn here. It tells us that line LN and line OP intersect at M. Find the value of x and the measures of angle LMO and angle OMN. So we have to find three different things. We have to find x and then what the exact measures of these two angles are. In any which case, if it only asks for the measures of the angles, we would still have to solve for x because we don't know what this value is. We cannot give a definitive answer. Alright, so from what we've known, we have a straight line here and an angle that is created in that. These will be called our supplementary angles, so that we know from here and here, when they add up, will equal to 180. When you add these up, they will equal 180. So there we go. We can now create an equation. We can say our 5, let me grab another color here. Let me undo that. Here we go. We can say our 5x minus 20 plus our other angle right here is a 3x plus 4 is all equal to 180. We have a plus sign in front of these parentheses. That means we can pull it out without having to worry about changing any signs. Distribute that positive 1 throughout. 5x minus 20 plus 3x plus 4 equals 180. So we're going to go ahead and we're going to combine like terms. You'll end up with an 8x, negative 20 and a positive 4, minus 16 is equal to still 180 on this side. Add 16 to both sides. 8x is equal to 196. Divide both sides by our 8. Both sides divided by 8. It's not a square root sign. That's dividing by an 8. We'll leave you with an x on this side equals, when we do the math, it will give you a 24.5. Alright, so the first part is complete. Find the value of x. There we go. I'm going to mark that as my answer. Now, I'm going to take that value and I'm going to place it into the separate angles right here. It wants to know angle LMO. So it wants to know this angle right here. So 5. Let me come over here and snag. Let's pick this color here. We've got 5. And now we have an X. Make that 5 look a little bit better here. Now we have an X, so we're going to substitute in what we got before. 5 times 24.5 minus a 20 will equal our measure of our angle. Alright, so feel free to place that into a calculator. What you will end up with will be, when you do the math, right here, a 122.5 minus a 20. So whenever we do this, we will get a 102.5 equals, and this is what we're after. So now another answer that I have is angle LMO equals 102.5 degrees. Go ahead and put here our other angle that we're looking to find is OMN. OMN, which is our other one right here. You can solve this one of two ways. You can say that, well, this overall is 180, so 180 minus 102.5. That will give you your answer. Or we can come over here and we can do just like what we did on this equation. We can set, we have a 3. There's an x. So I'll put in my 24.5 and plus 4. Whenever you do this, you will get a 73.5, I do believe, plus 4. That's equal to whatever we're after. 77.5. Alright. 77.5, and these are in terms of degrees. Now, as a quick check, we've already got them lined up right here. Let's add this up. That would be a 0, carry the 1, 7, 9. You've got the 1 that's carried. That's going to give you another 0. It's going to be 8, 180. 180 degrees, so that checks out. Alright, let's move lastly to our example 5 real quickly, and let's look at what it tells us instructions wise. It says that we have a ray CD. A ray right here, CD, is perpendicular. That's what that symbol means, to line AB. If something is perpendicular, then we can go in here and we can say this is going to give us a 90 degrees. Tells us what the measure of angle 1 equals. 1 is a 3x minus 2 degrees, and it tells us that 2 is a 4x plus 1 degrees. 4x plus 1, and those are degrees, and these are the measure of angle 2. This is the measure of angle 1 equals that. Find the value of x. Alright, so what we know out of this is, since we have a right angle made right here, this will also make a right angle. That means the sum of these two angles is going to equal 90 degrees. So, sum means we'll add them together. I will take my 3x minus 2. Now I will add my other angle, 4x plus a 1. And this equals complementary angles right here. They will equal 90 degrees, which I don't guess we needed the 90 to solve for this. We'll just leave it at 90. We have a plus sign in front of parentheses. We can go ahead and take that out. So 3x minus 2 plus 4x plus 1 equals 90. Alright, combine our like terms. You will be left with a 7 and x minus 1 equals 90. Add 1. 7x equals 91. Divide both sides by our 7. X equals 13. Now let's check and make sure all it's asking us, find the value of x. We don't have to plug that in any further. Our example 5 is now solved.